Ladies and gentlemen, friends and family, Toonies, I come to you today with a heavy heart to pay homage to one of Flat Earthers, well, not one of their favorites, but one of Flat Earthers' most desperate attempts to explain why things go down. Incoherent Dielectric Acceleration, or I don't know, they call it by different names, but it has been through a few hard times lately, and much of it has been at the hands of Bryant Myers, who is with me.
I think we got it here, MC.
Yes.
Can you see the? Okay, so we got the.
It looks good.
Now I did get some like last words from Witsit before this is kind of his last comment, because I was trying to kind of get out of him. It's okay, where does this 9.8 all the base, just to try to make sense of it. So, and like, how can it be super strong and then be super weak? How can it sometimes be attractive and then sometimes be no charge or negative or positive charges, charge and discharge, right? So there's like these four different explanations that he has. And so this is the last comment I got from it on YouTube. So he's saying there's a downward electric flow on the earth that sets the up and down. No one is claiming a giant force pulling things down to the earth. The downward bias sets the up and down. There is provably an electric flow down on the earth, and it's very weak. Okay, now, was I mishearing him when he said it's 10 to the 36 times stronger than gravity?
He did say that. Well, all right. So he said that the electrostatics in general is 10 to the 36 times more powerful than gravity.
Right.
And now he's saying that this isn't electrostatics. Maybe he's saying this is electric flow.
Electric flow. Well, the gravity is kind of weak. So if he's going to use electricity or electrostatics to create gravity, it's got to be kind of weak then, right? Because if you're going to, so it's kind of weird that he said it's so much stronger than gravity, yet he's trying to use it to explain gravity. So it's like there's a little problem right off the bat with there. And so this is kind of the main thing. And I kept going back and forth with him with email debates, and he just can't, there's just nothing they can do to get 9.8 meters per second squared outputted from their model. I mean, they don't have a model. That's the problem, right?
Yeah.
And so all he had was these electric universe papers that you and I have kind of looked at, Morton Spears and others. And it's like, okay, they come up with the value for G, and then you could say, okay, now we can calculate little g, but it assumes a spherical Earth.
Yeah.
So it doesn't help.
Yeah. So for people that don't know, Gleam and Atlas 6355 is mentioning this. Gleam, who is not a flat earther, he knows that the Earth is spherical, but he likes to LARP as a flat earther. He posted a whole bunch of electric universe papers on Witsit's video. Witsit sent them all to Bryant, but Witsit did not read them. Not only it's one thing to read it and not understand it. He didn't even read them. But most of them agree that mass attracts mass, and they were different proposals for how mass attracting mass might have an underlying electrical component to them. Their hypotheses is what they are essentially.
Yeah.
And none of them claimed that mass does not attract mass. They all affirm mass attracts mass. It was just about where it was derived from.
Yeah, and they all claim a spherical Earth too. None of those papers are going by the Earth being flat. And so now, just so that Witsit, because he loves, you can see from this thing here, he loves the claim that I'm straw manning him. So can you play those video clips, everybody, just so he can't say that we're straw manning him? Because I want him in his own words to lay out his model. Yeah, so that way we can go through it and not put words into his mouth, right? We're using to use his words and his model.
All right, I will. Do we need to see? I don't know if we even need to see. But this is. That? Oh, all right. If you play it, it might come through. Then you can control it. Oh, but no, it's come. Oh no, wait. We see it here. All right, hold on.
Okay. So a positive charge, potential charge. So.
All right. Did you hear that?
I heard it. Yeah.
Okay. Well, here we go.
So what we actually see is that we have atmospheric electricity on the Earth. So we have an increase, equipotential increase. It goes up 100 volts per meter. Okay? So there's positive charge, potential charge increasing up from the surface, 100 volts per meter. Now, the only way that that can be replicated or accomplished in any way, in any actual demonstration in the world, is you have to have two Gaussian surfaces. You have to have a surface above and a surface below to get that equipotential increase. It's the only way. There's no other way that can be demonstrated. So,
okay, so that was number one. So we're going to play by his rules. Okay, so we're actually going to go by his explanation, and we're going to it's going to be killed dead, even in their model. So we're going to assume that what he's saying is true, and we're going to show, and then we'll kind of add more things to it after that. But so can you play the next part? So this is a setup. So he's basically setting up. Can you still see my screen?
Yeah, yours is on right now. Yep.
Okay, so he's basically setting up this 100 volt per meter equipotential sort of increase in voltage. Okay, and now the next little clip, he's going to talk about the downward bias, and this is where he mentions 9.8 meters per second. So if you could play that one now.
Flow of electricity on the Earth. So that's what gives you the downward bias. So when something fluctuates between 9.8 meters per second squared and 9.73, well, okay, because electrostatics is super weak. So the change in electrostatics would never be drastic. It's an agreed upon average.
What? I thought electrostatics was 10 to 39 times stronger.
Not all things go down. Sometimes things go up. So we can actually manipulate that variable. We can prove it's there. All matter has it. It's tangible. We can actually manipulate it in an experiment and prove that it causes things to go up or down.
For those wondering, I was doing a live commentary, and so you're seeing my live commentary get added in. All right, go ahead, Bryant.
Yeah, so I mean, I just like your version better anyway. So now he's saying, okay, so from this gradient, there's a downward bias, and I couldn't get out of him. It's like, are you talking about just a one-way vector with no magnitude? That doesn't. I mean, if you're dealing with a 100 volt per meter electric field, that provably has a magnitude. I mean, you're using these numbers, right? You can't just say that it's a downward bias only. It sets, but then what causes things to go? Where does the 9.8 meters per second come from? He just says it's an agreed upon average, and
it's measured. It's not an average.
It's measured. I know.
It's a measured average, not an agreed upon average.
So he just wants to kind of use that number and then plug it into all the equations, at least at sea level, that we have in engineering and everything, and somehow that totally is fine with his model. Now the last part is, this is where the black swan comes in, the next clip you're going to play. Because now he's going to admit that, I pinned him down during the debate. I said, okay, what's your F? Because we, with our model, I don't want to give it all away here yet, but with our model, we actually have an equation, and we can predict G at any altitude. We use the Cavendish to get the value for big G, right? And then we can use that, put that into Newton's laws, and then we can calculate little g at any altitude, escape velocity and all this other thing. So, but even at sea level, we can at least have a derivation of G from our model. And he doesn't have that. So I pinned him down. I'm like, okay, what's your force equation? If it's not gravity, it's got to be Coulomb's law, right? Because you're talking about an electrostatic gradient of 100 volts per meter. That is electrostatics. Electrostatics is governed by Coulomb's law. I mean, there's no Walter Lewin, the guy that you love to quote so much. He's got a lecture on electrostatics, and guess which equation Walter Lewin derives for us? Coulomb's law.
Coulomb's
law.
law.
Thanks for everybody's patience. I just wanted to do this so that everybody can hear that it's coming from his words, and I'm not straw manning him. So can you play the last little clip, and then we'll get in.
Yep, here it comes.
Force, that says F equals. So yeah, force equals mass times acceleration.
Okay, but again, acceleration. Where are you getting that from electrostatics?
That's what everything is. It's literally all electrostatics.
Use Coulomb's law to derive that. Then, if you're using electrostatics,
we could use Coulomb's law, but it doesn't matter. The thing here is, my God.
That's Walter Lewin, when he did his presentation on electrostatics, he derived
it's
Coulomb's
gold.
law. That's the
gold. Coulomb's law.
Electrostatics.
I know. Yeah, it's almost exactly the same as the gravitational law, but it's just charge is different.
That last part was priceless. He's saying because it looks like Newton's law of gravity with K, Q1, Q2 over R squared. He says it's the same, but yet he says it's 10 to the 36 times stronger, and it is. So you see the contradiction here. He's saying it's the same as gravity, but it really is 10 to the 36 times stronger. But now in this situation, somehow it's super weak. Somehow Coulomb's law has morphed into something that applies to atmospheric electricity that's totally not what we know Coulomb's law to be. So, so I just kind of want to come right in and just with the black swan. Let's not waste any time here. So with Whitsitt basically, acknowledging that Coulomb's law, it's what we need for electrostatics. I mean, there's just no debate about that, right? So, well, actually, let me do these two figures here first, because it takes it through it more pictorially. So the problem here is that, the problem is that the gravity is when the acceleration due to gravity, the inertial mass cancels the gravitational mass. Actually, let me just show this right here real quick. So over here, we have, when we set F equals to ma equals to Newton's laws, we can kind of regroup it to ma, and here's our acceleration. And because inertial mass is equal to gravitational mass, and this is what led Einstein to general relativity, right? He realized the equivalence of these two masses and that they canceled out. And this gave rise to the curvature of space-time that he developed from this insight. And so because of this, the gravitational acceleration is constant at sea level because the masses cancel. Okay, now, now here's the black swan. Now with electrostatics, we do the same thing, okay? We set F equals to ma equals to QE. And for those that maybe don't know, QE, the electric force, is basically just Q or KQ over R squared. So it's basically the force per unit charge, just
So
simply.
K is a constant, Q is a charge.
K is a constant, Q is a charge. And the beauty of doing it in the electric field format is that you can just, it's like the sound of one hand clapping. You only need one charge, and from that comes the field, okay? So you don't need an action at a distance. The field formulation is also really nice in gravity, even before Einstein.
Yeah, and so to give a little background to people, Coulomb's law is about 2 points, 2-point charges, and then there's a field version of that. You can derive the field version of that. That's what we're looking at here. This Q times E.
And you're just dividing by Q. So essentially, it's Coulomb's law divided by Q. So just for clarity, this is Coulomb's law here. And because he's listing it as 100 volts per meter, that is an electric field. So it just kind of flows into this equation better than the expanded form of Coulomb's law, the 2 points. So so when we do this, we set and we solve for A. So we got F equals ma equals QE. So A equals Q over M times E. I hope everybody's following. And now, I
have to give some commentary on this. If you're not following, that this is saying that the acceleration is relative to the charge and inversely proportional to the mass.
Yep.
Okay.
exactly.
The
So
charge
we have
of the
our
object.
100. So even though the electric field is constant at 100 volts per meter, and oh, by the way, when you do all the units, it does come out to meters per second squared. When you use the K, it comes from the K constant.
Yeah.
You know, a lot of the units are, so you do get meters per second squared out of this because this is 100 volts per meter times Coulomb charge and divided by mass. So here's the thing, look over here, gravity constant because inertial mass cancels gravitational mass. Over here, there's no equivalent to an inertial charge canceling a gravitational charge. So you see the problem? So if we double the charge, we double the acceleration. So if
you change the polarity of the charge, you change the direction of the acceleration.
So I'll get to those pictures in a second.
Okay.
So now, but it's also mass doesn't go away either. So now you have also to divide by mass. So the only way you can get 9.8 meters per second squared is to fiddle with a charge and a mass that makes it work. But then it's going to be, it's not going to be the same for. So everything is going to have to be.
If the charge is the same for everything, then it's going to be based on the mass.
Yeah.
Which you'd have to have a very specific mass.
Yeah, a very specific mass. And So, but again, the point is they're not constants. Like you said, acceleration varies directly with the charge. So you literally double the charge, you double the acceleration. I mean, you double the mass, you half the acceleration. I mean, it's just we're over here, we have this beautiful, smooth, constant acceleration across the surface of the Earth, 9.77 to 9.83. Over here, you just have chaos. I mean, if you use this equation, just to kind of drive this home here, I drew this little chart. Let's just assume, there's no gravity. Just turn gravity off. You're still going to have those same problems of doubling the charge.
That's their claim, of course.
Yeah. Okay, so again, but then when we start up on a scale, again, I don't know what that means. I even have switch. It's like, okay, if there's no gravity, and I stand on my scale, you're agreeing somehow that there is mass or density, right? They say density and buoyancy.
Yeah.
But how does that all fit in with this? But even if we just turn gravity,
they try to not say mass. For some reason, that's kind of the trend. They say density instead of mass, but density is just mass proportional to volume. It's still mass,
right? And Flat's in that debate with FTF, I mean, he didn't seem to know what density was. They really don't seem to know what density even means. And so, but here's the thing: unfortunately, if we have a negative charge, now things will start to levitate. They'll go the other direction.
And it would not take a whole lot either. If there's no downward acceleration due to gravity, if it's at zero charge, right? If it's at net zero charge, it will neither go up nor down. It would just hover. And a small applied negative charge would cause it to go up right away. You don't need large amounts of negative charge. Small amounts of negative charge would make it happen because there's no additional downward acceleration, according to that.
So, I mean, right. So, and again, I kind of put this is both formulations of Coulomb's law here. So you got, this is electric. So you can see. I mean, you got these so you got these three possibilities. And the thing with gravity is it's always down. In fact, just kind of for fun here, these are just kind of evidence-based observations of gravity. So it's based on mass attracting mass. It's always attractive. There's no polarity, right? There's no. I mean, I know some people try to claim there's anti-gravity, like Whitsitt and Dearth. With their little balloon, they like trying to show that this is It's not anti-gravity, guys. It's an electrostatic force you're playing with. It cannot. Well, we'll get to the cannot be shielded here in a minute. But it's a slow 1/r² drop off, which is spherical symmetry, by the way. Whenever you have a 1/r² law, that is coming from spherical symmetry. This is why, again, they're never going to get 9.8 meters per second to work because it comes from a spherical symmetry. And like I just said, it's the gravitational acceleration is constant at sea level. Oh, and this is something that kind of dawned on me, MC. You know how they have all those memes about Australia being upside down, and they just keep going on and on about that. Well, if their electric field sets a downward bias, I mean, it's like, that's your version of up or down. I mean, you're calling it something different, but it's the same principle. It's like, why is it so hard to understand? But it has to do too with our vestibular system registers only acceleration, right? We can't really feel it. We can't sense a constant velocity, and actually no meters can sense it either. So
it goes back to relativity. Constant velocity cannot independently be measured.
Yeah, can't be independently measured. There's no constant velocity meter. Even your car is using like the rim, whatever, your rim speed on your tires or something.
The tire touches the road. That's how it gets that.
Yeah, it's not measuring the constant velocity. And this is playing by their rules, MC. We're given Whitsitt as two Gaussian surfaces. He can have them. We're not going to even talk about how the electric field drops with altitude.
I want a disclaimer on that. There is no need for two Gaussian surfaces.
No, there's
but
not.
Let's accept his hypothesis that there is two Gaussian surfaces. It doesn't change anything.
It doesn't change. So we're playing in their world right now, and this still kills it dead. This is why to me it's a black swan, because we're actually playing by their rules. We're living in their world, using what Whitsitt just said, and he can't claim a straw man because we just heard him say it. So
he said Coulomb's law. Yeah.
And he said Coulomb's law. I mean, he has to. If he's going to use 100 volts per meter, I mean, honestly, they're better off just saying heavenly energy because,
it leaves it vague.
It leaves it vague, right?
Their best hope is to never say anything testable.
I probably shouldn't have even said that. Now I probably
Now you gave it away. They're going to start saying they're going to give up.
It's just going to be the next thing that's going to come along is going to be the ether and heavenly energies that we won't be able to do any.
I mean, his Witzit's Papa Flurf number 2 is Bob Nodell, and he says he have heavenly energies. So whatever.
Yeah. But this again, and forget that the dome. I just figured out after the debate actually that the second Gaussian surface was the dome, and forget that was short out because it touches the ground. I think it was actually one of your people left that comment. So I'm not going to claim that
wasn't me.
But,
yeah.
But
unless the dome is magically suspended and it doesn't touch somehow.
It doesn't touch. Yeah, somehow we're going to leave a little distance. But again,
flat earthers, make up your mind. Is there a dome? Is there not? Does it touch? Does it not touch? I mean, you should get together in it, like in a convention or something, and all agree on your story. Hey, this weekend you're getting together on a convention. Maybe you should have a session where it's like getting our story straight session.
Yeah, getting our story straight. So really, this to me is the black swan. This kills it dead. I mean, how can we get the paddles out and bring it back to life?
Witzit has been trying. I mean, he gave it mouth to mouth. He's been sitting and doing the chest pumping on this.
Yeah,
I mean, they're trying to get the electric paddles, the electrostatic paddles to.
Yeah,
it's not working. It's not working.
But see, now, if this is bad enough that you're dead. Now, I'm not a big fan of beating a dead horse, but as far as beating a dead flat Earth theory, now I'm all for that. But it actually still gets worse. I mean, it's this. Yeah. And actually, this is still playing by their rules. Okay, we're actually still in their world, in their rules. Electric fields can be provably shielded. And again, remember in the debate, Witzit said that you can get an electric field meter inside a Faraday cage, and it will say 0.
For clarity, Witzit claimed that electrostatics cannot be shielded.
Yeah,
absolutely untrue.
Gravity cannot be shielded. So that's a fact. I mean, gravity is charge independent. I mean, it's actually the only way you can shield gravity would be a huge, massive shell of mass. And then you could maybe shield the gravity of a mass inside of that big, huge shell of mass. But here on Earth, we don't have anything like that to shield gravity. So gravity goes through everything. Gravity waves from LIGO went through the entire Earth all the way through. It doesn't get shielded. So this is something we know empirically. We can measure and we can see that nothing shields gravity. So this again is another way that it just kills it. I mean, electric fields can be shielded, and it actually comes from kind of a cool bit of science here. We need to use Coulomb's law because this version of Coulomb's law is for like a vacuum or with the dielectric constant being 1, right? But in reality, the atmosphere is pretty close to 1. Air, you can see. So we can pretty much safely use that equation in the air. But in different materials that have different dielectric constants, the electric field gets shielded. So an dielectric constant of 50 would be 50 times shielding, right? Which is the human body, by the way, it shields electric fields about 50-fold. And it's because water has such a high dielectric constant.
So for reference, the D in incoherent dielectric acceleration, they say, and you're using the word dielectric as it shields electrical charges, right. and inside a capacitor, the ideal, the generalized capacitor is 2 plates. And between those 2 plates is a dielectric material or any material that has a certain dielectric property. And a vacuum has a dielectric constant of 1. And they don't use that in capacitors generally because it's not a very easy thing to make. So they usually put something between it. Sometimes it's an oil, some of the old ones, an oil-soaked piece of paper.
Yeah. And again, the better the dielectric, the better it can keep the charges separated, because you don't want a leaky capacitor where the charges start to go from one side or the other. The whole point is to store energy across this gap. And so, yeah, I didn't think about that. Incoherent dielectric, just the word dielectric, that's a big part of, that's a big flaw in their
They're
model.
just throwing that word in because it sounds fancy. They're not using it in the way that dielectric actually is being used in actual work.
Yeah, this is the version of Coulomb's law in materials. So you can see this little E right here. So we have to actually, we're just taking this equation, now we're dividing by the dielectric. So again, you can see the force with water, it would be diminished by 80-fold. And I guess human body is about a dielectric of 50, right? So electric fields, so if somehow this dielectric acceleration was based on electrostatics, then the outside of our body would getting more forces than the inside of our body, because it's getting shielded, and you have all this crazy things going on, right? It just leads to nonsense when you use that, try to use it for gravity.
That would screw up our sense of balance.
Oh, everything, yeah.
It's wow. I didn't think of that.
This came to me. I'm like, when I look back in my electrostatics courses, I'm like, wow, this is really bad for them. This is even worse than it was, because it just can't work. On so many levels. And metals. Guess what? Guess what the dielectric constant for a metal is? Infinity, because electric fields inside of a conductor are zero. So now you have another problem.
Yeah.
And this is, by the way, why Faraday cages shield electric fields, right? Because it's the conductors, it's buffering, because the dielectric is infinity. So a conductor will be shielding 100% electric fields.
So only the bottom layer of atoms on a hunk of metal, or maybe the top, or maybe the outside, would contribute to its downward weight. The entirety of the inside of a conducting metal would not contribute to its mass, or not its mass, its weight, its downward weight. So you could easily pick things up then of any size. It'd be delight.
Yeah, it'd be like a new buoyant force of sorts.
My goodness, people.
And so see, when you put a metal in an electric field, what's happening is that there's the free electron. So the positive side of it, the negative electrons go to the one side, and then the other. So you got all the electrons are grouped on the positive side, and then so it basically creates a net electric field of zero inside the conductor. So this is another problem. It's like, well, we know gravity affects all these materials the same, and if you have magnets and metals and paramagnetic materials, they all interact differently with electric fields and magnetic fields. And then you have the magnetic field of the Earth still that's there, right? So, so anyway, this is a big problem. In fact, the whole dielectric and incoherent dielectric acceleration, it's a big part of their problem.
It's a filler word.
It's a filler word that is part of their demise. They're literally that's the worst. It's not helping their model by using that word. And again, I just kind of hinted at the different materials here are affected by our electric fields in different ways. The Lorentz force law, QV cross B. When you have an electric field and a magnetic field, magnets, if you drop a magnet electric field, there's going to be forces acting on it.
Yeah.
And if you accelerate a conductor through an electric field, then you got Faraday's law. When you got a changing electric field relative to the mass, you're going to induce little microcurrents. And you got some Lenz's law effects of resistances and things like, all kinds of weird things are going on when you got these different materials. If it is all electrostatics, that is to say. So, and so, by the way, this is still within their world. We still haven't gone into the real world yet. It still keeps getting worse. This is why it's a funeral. All of that, everything we just said applies to their world. And it still kills it dead. Everything we just said kills it dead.
We're applying their claims, right? They never work through it. We're working through it. We're just applying their claims, which is every time you apply the claims that flat earthers give, they don't apply their claims. They just have a vague idea of it and think that's it. But you go and actually apply it. When you actually apply perspective to the sunset, you find out the sun could never set due to perspective. but they don't know how to actually apply it. They say, well, you're doing it wrong. Well, what's the right way to do it? A different way. Which way? Don't know.
You got, okay.
Yeah.
So, okay. So now part two, now we're going to come to reality now, MC. We're actually going to come back to the real world a little bit. But we're going to do so with actual studies that prove that what we're not prove, but that give us evidence for what we're saying here. So now when we get to the real world, what we find is that number one, the electric field is not constant. It does decrease very quickly with altitude. In fact, as we'll see, by 50 kilometers, about 31 miles, it's down into the millivolts per meter. And it's almost zero because it's a highly conductive. Remember what we said about conductors? Their electric field is zero, right? Yeah. So this kind of, it's a little bit below the ionosphere, but there's a very highly conductive layer of the atmosphere below the ionosphere. And so as these layers get more and more conductive, it turns out that electric field is falling off exponentially because the conductivity of the atmosphere is going up exponentially. So this totally does not match reality, because at 31 miles up, where the electric field is now zero, provably by atmospheric science, guess what the gravitational acceleration is at the 31 miles up? About 9.7.
Yeah, not
it
zero.
hardly dropped off at all. And it's because the 1 over r squared is big R, right?
And what was Witzit's attempt at this?
He played some dodgeball there. I think that's when he started to ask me about rain, like how do clouds stay up in the sky or something.
Yeah, he kind of got off. I saw what he's trying to do there, because you said like at 30 miles high or something, right? And he's like, I don't claim that there is such a thing as 30 miles high. Oh. Or I don't even know what is there. Well, it's not, things have been that high.
Right. You're right. He did say something, and I don't know. He told me at one point, I thought he told me at 50, they don't believe in it. I don't know the word is believe, but they don't kind of acknowledge anything beyond 50 miles up.
So they do acknowledge 30.
And that's what I'm saying. It's like, well, wait a minute, this is 30 miles up. This is not 50. So where do you draw the line? Where is it that we can't talk about reality anymore in your model? Is there some magic? I mean, I thought the dome was like 3,000 miles up or something, but they don't know, right?
They don't know. Yeah. And Austin is of the I try not to make claims.
Okay.
Of course, he makes lots of claims. He said 2 Gaussian surfaces are necessary. Well, that's a claim. Where's that?
Yeah.
I'm sure he just heard it from somebody.
Well, but if he's going to acknowledge this 100 volt per meter electric field, the other Gaussian surface is at about 31 miles, because that's where the charges are. Because again, it's like a parallel plate capacitor, right? You know, the conductor, you got all the charges on the conductors, and you got like a dielectric in between. And now, you know, the atmosphere, it definitely is a leaky capacitor, right? Because we get lightning and there is a measurable current from the upper layer to the earth, right? It's just a very weak current.
Yeah, it's very weak.
And it's very, very weak, but it's like, well, your model is dependent upon this second Gaussian surface, to use his words. So you can't dismiss 31 miles up. And we can, this is again, we can see, you get accelerometer, gravitometer, whatever, you can measure these vibrations as you go up, and you can see, oh, this is dropping off by this very, very slow rate. And the electric field is dropping off exponentially. Well, anyway, let's just
I think it's worth pointing out that it would reverse polarity at a storm. Now, Austin's defense of that was ridiculous. That's a letter E there in that. Yeah, this one as well. I was going to get to that. I just wanted to look at the Carnegie study here a minute, because not only does the electric field drop by altitude, exponentially, but this Carnegie curve is very well validated. I mean, it's incredibly well researched. And it shows how the electric field will vary by 15% during the course of any given day everywhere on Earth. And it has to do with the whole, statistically, when lightning strikes the most during the dry times of day or whatever, there's a certain statistical thing that goes into this, but it's a very well mapped out curve. And it's also seasonal too, where the electric field changes by season. So remember, the electric field or the gravitational field in the Earth is changing by 0.7%. Oh, and this is
This is something that,
across the entire surface of the Earth.
again, they kept going on even after the debate. Whitsitt kept emailing me saying, admit you were a liar about gravitational anomalies. I'm like, okay, Whitsitt, I admitted that I wasn't aware of the rainwater studies on creating gravitational anomalies, but Walter Bislin, one of the smartest people I've come across online, he sent me this. And actually the anomaly due to the rain was much weaker than I even thought.
Yeah.
And so they're like, so he's going on about me not knowing about this. Look at how many decimal places here, due to the gravitational.
Down in the 10th decimal place.
No, this is an anomaly. I won't say that I didn't know about this, but Whitsitt, it doesn't change my numbers at all. And even Bob on Goldbusters, if you rewatch that video replay, he kept going, Brian, it does change. They're trying to make it sound like the weather is creating these wild fluctuations in gravity. If you go back and watch your replay and look at Bob from Goldbusters comments, he's making it sound like I made some fatal error in my presentation. And this fatal error is, look at how many decimal places.
So it's, I said 10, it's 7. But to be clear, the change, this particular change is due to the mass of the water.
Yes.
The mass of the water in the area around the gravimeter changed, causing this particular change. So it doesn't help you, Austin and Globebusters, because it's a predicted change. It matches reality. You don't actually have a mechanism for why it changes down in that 7th position.
And I sent him the study that showed these numbers based on this calculation. And I said, Whitsitt, if it's electrostatics that's causing these anomalies, show me a source. Show me your research. He sent me nothing. They're literally.
He sent you Gleam's papers is all he sent.
Well, but he didn't send me any proof about these atmospheric weather anomalies that basically he made it the way him and Bob, if you go back and watch the comments from Bob, it makes it sound like weather is like warping space and time in some really radical way. And that somehow I am way off in my numbers. And it really had me thinking, it's like, oh shoot, did I miss something here? And as soon as the debate was over, I'm like looking this up and I'm like, wait a minute, guys. This is, I didn't think it was as weak as what Walter sent me, but it was still very weak what I initially sent to Whitsitt. And it's like, you're really making this big deal out of this me not knowing about something that creates a change. So anyway, not to harp on about that, but the point is these are measured, geodesists. We know these anomalies are very carefully mapped out, right? The geoid variations, all these, and it is this very, very, very well documented. Here, I have it right here. The lowest gravity is in Nevada, this mountain here in Peru. Oh, I'm sorry. And then, this mountain in Peru, and the highest gravitational strength is in the surface of the Arctic Ocean. And they know this to 4 decimal places.
Those measurements probably are about 9 deep.
Okay.
Yeah, because the absolute gravimeters are 9 or more, and the relative gravimeters are about 9 decimals deep.
Oh wow! So that's figures. So geodesists have our gravity mapped very, very well.
Yes.
And so they try to use these gravitational anomalies like that's some big like they got this big secret weapon in their pocket. It's like, oh, you didn't know about gravitational anomalies, Bryant. It's like, well, maybe I didn't know about the one you mentioned, but it doesn't change the numbers I gave you through the debate. So of course, what we're talking about with the weather now, we're talking about exponential drops going up in the atmosphere.
Now, was this picture in one of Austin's citations? Wasn't it?
I'm not sure. Maybe I missed that, but he.
I could be wrong, but I seem to recall of a stream where he was on with other flat earthers and not you, and they had this particular.
Okay. I got to see what they have to say about this.
Which I love the irony, of course, but anyway, go ahead.
Yeah. So just kind of moving along here. this atmospheric electricity textbook is very validating what I'm saying. Even Richard Feynman in his wonderful chapter, by the way, it's free online. You can read Feynman's lectures on physics. There's a whole chapter on atmospheric electricity. And he knew, for his time, he knew an incredible amount about this that really hasn't changed a whole lot. I mean, they've learned new things, of course, but this more recent textbook talks about a similar, they actually list at 30 kilometers, it's already 300 millivolts. So that's even worse. That's like 18 miles up, right? Or 19 miles up. And it's already at 300 millivolts.
To be clear, that's a capital M, which usually would mean mega, but then in brackets you see over here.
Right
behind it. Yeah, SIC means it was their typing. They typed that, and the author who reposted it didn't correct their mistake.
Okay.
Should be a lowercase m instead of an uppercase m.
Yeah, that kind of caught me too off guard. It's like, is that 300 megavolts?
It's millivolts. But
it's milli. It's definitely milli because you can see over here the range.
Yeah.
And so again, exponential drop off. And so, let's get to the big one now. This is where it just it kind of all goes off the rails totally. I mean, and it's already off the rails, but this just totally annihilates their whole model. And so again, I couldn't understand Whitsitt, like how in his mind you say downward bias, okay? And there's literally, anybody can Google it. Google how many lightning strikes a day, 8.6 million is what comes up. And I don't know why Whitsitt was trying to get me to say that the whole field was flipping. I'm like, Whitsitt, I'm not saying the whole electric field of the earth is flipping. I'm saying that around each lightning strike,
it's localized.
Polarity reversal. It's a localized polarity reversal, right? And so not only is the field switching, well, not only is it going up by 100 to 150 fold, but it's flipping polarity. It's going the other direction.
So I mean, Austin's defense of this, his attempted defense was, oh no, I meant the field of the entire earth, not just localized. But you can't do that. If it changes locally, it doesn't matter what's happening elsewhere at your location.
We can measure the electric field. If you're going to use 100 volts per meter, that's a measurable quantity.
Oh, but wait. Oh, no, it gives the it just gives the bias. It doesn't actually give the magnitude. Is where he went.
Well, then now,
so it would slam you to the ceiling. It
doesn't help you to say that. I mean, you're whatever that just means that whatever the strength is that we're feeling due to gravity, now that same strength is turning around and going the other direction. If you take the magnitudes out, right, MC? I mean, let's just strip the magnitudes out, and we're just dealing with the vector only,
right? It's just the bias, yeah.
It's just the bias. So whatever that bias is, it's taken a 180-degree turn, and it's gone the other direction. So if we want to play the weather vane game, where we're just going with an arrow and nothing more, then the whole weather vane just went from east to west or north to south, right? And so that means, based on your logic, that we should be levitating. And then, get this. Both Bob at Globebusters in the comments and Dearth both say, well, things do levitate around lightning strikes. They both said that.
Everything would. Everything. Not some things, not very light things that have already a charge on them. Yeah. Everything. And the more... The more heavy something is when there's no lightning, right? The equally more heavy it would be to go up when there is lightning.
Yeah. And that should affect everything, not just charge. I mean, again, gravity is charge. We know this. It doesn't depend on charge.
Oh, look at this. Oh, all right. We got Flat Earth Dweller who's trying to defend this ridiculous idea. Says locality is irrelevant. The acceleration is caused by the electric charge from the firmament to the earth. Well, except that there is a measured inversion of that electric charge, Flat Earth Dweller. It doesn't help you to just lie about things. Locally, it changes.
But Whitsitt, Dearth, Bob, they all use 100 volts per meter. That's not just a general heavenly energy expression. That's a very specific, technical, measurable term. So what he just said doesn't hold water here, because your guys, and maybe he's got his own theory about this. Maybe he's got a new theory, but this is not what the Globebusters are teaching. Globebusters is talking about 100 volts per meter. And again, that's measurable, and that turns around directions and increases by 100-fold. Sorry, but that doesn't cut it.
Oh,
So,
here we go. Flat Earth Dweller comes back. The voltage difference charge is only very close to the lightning. Oh, so then that still doesn't help you, because during a lightning strike, things would fly up proportional to how much they go down. But of course, that lightning strike, assuming that, accepting your claim, right? Accepting your claim.
yeah.
Around the lightning strike, the things that have 100 pounds down would have 100 pounds up. Or if the magnitude of the charge generates the magnitude of the downward, then it wouldn't be a 100 pounds up during a lightning strike.
Guess what, Flat Earth Dweller? Lightning hit my house, and this is true. I was literally 6 feet away when it happened, and it knocked me back, and not up. I mean, it was more the shock wave from the sound wave coming from the strike.
Yeah.
I mean, I didn't fall over even, but I mean, it was sort of like this, but there was no gravitational effect, and I was 6 feet away from it. I mean, I kid you not, I'm not exaggerating. I was at my desk, and the lightning hit the corner of the house, and it totally blew out, like my Wi-Fi just exploded in the telephone line, because the lightning hits the lowest ground, the lowest voltage part, right? And so it just exploded out, and it was pretty scary. That's never happened to me before, but there was no gravitational effects. I mean, and I was 6 feet away, so I was very much within that very high voltage polarity reversal. So I've experienced firsthand, and you don't know what you're talking about.
Well, to continue to make you cry, Flat Earth Dweller, inside of a Faraday cage, that whole charge is neutralized.
Yeah.
Things would float inside of a Faraday cage.
Yeah.
They don't.
But again, there's 8.6 million lightning strikes a day. And here's this little, so you can see from this chart here that the gravity is varying by 0.7%. The electric field, I don't care, even if it's in the localized area of the lightning, gravity doesn't vary in those areas. Gravity is, yeah.
You had a different one that showed that throughout the day it varies.
Oh yeah,
right?
This is the Carnegie curve. Yeah.
There you go. So the Carnegie curve shows that this 100 volts per meter varies throughout the day, flat earthers.
Yeah. Yeah.
Okay. That's not, from the dome to the earth, and it's outside of this lightning idea. The weight of everything would vary proportionally to this change in it wouldn't
15%. Yeah, 15% plus or minus.
Yeah, it wouldn't cause you to fly up as it varies, but it would drastically change the weight. So to be clear, mass doesn't change, weight does throughout the day.
Yeah, you'd be weighing more like around dinner time, and then you'd lose weight in the morning. And it's a 15. This is not a small change, 15%. So the gravity, again, across the Earth, 0.7% differential from the Arctic to this mountain, right? I mean, and that's a big distance away. So you go anything that's a close distance is.
This is a good point. PhD Tony, who works with gravimeters, says that they shield gravity measurements in Faraday cages. So when they have these gravimeters that are 9 digits, 9 significant figures deep, they do it in an evacuated chamber. They do it with consistent temperature. They do it in a Faraday cage. There's a whole ton of controls that they do this, including Faraday cage. So if it's in a Faraday cage, a gravimeter would always read 0.
Again, that alone, I mean, is you can't. Witsit tries. Remember during the debate, he doubled down on it.
Yeah,
I kept saying it's like provably, Witsit, electric fields can be shielded. I mean, you can get very, very expensive electric field meters that could measure. I mean, inside a Faraday cage,
it's like your first week of an engineering class, right? Of electromagnetism. You cover that kind of stuff, right?
Yeah.
We both took those classes, right? And
Yeah.
to say
Right.
the absolute insanity to try to claim that a Faraday cage cannot do what a Faraday cage does.
What it does.
Shield. It shields.
Electric fields.
It fields electromagnetic fields as well. It's
Well,
a
and fun
grounded.
fact, by the-
It's grounded. The whole outside is grounded. It's all at the
Well-
same electrical potential. Oh my God.
Well, the fun fact about electromagnetic fields, like say your cell phone, it's the magnetic component, meaning that's just getting detected. So when I used to do this little demonstration, put my cell phone in a Faraday cage, and the bars go down, but there's still something there. It's because the magnetic fields are harder to shield than electric fields. So electromagnetic waves, you got the magnetic component mainly coming through in those situations. But a pure electric field, and again, Whitsitt very clearly says it's all electrostatics. He says everything's electrostatic. So that doesn't include magnetism by definition. And he still uses incoherent magnetism to explain the nuclear stuff, which I don't want to I did a whole video on this and you posted it, so we don't necessarily need to get into the whole nuclear, but that's another big problem with his whole electric model is he's trying to make the electrostatics cover everything. So not only does it have to cover the very weak force of gravity that extends out to the universe and kind of is the main on the larger scales, but also he's got to now use the same force to cover the nuclear force, which is now 100 times stronger than the electromagnetic force, right? And it's literally holding, within the quarks is holding these oppositely, or these same charge objects together when Coulomb's law said they should be flying apart. And again, Whitsitt seems to think he's like, quarks have charge. Didn't you know that? It's like, yeah, Whitsitt, during the debate, right? He's trying to say, you didn't know that quarks have charge? It's like, yes, they have charge. They also have mass. But then there's this new thing called strong nuclear force that you're just not getting.
Yeah. So Whitsitt twice now, at least, has said that the nuclear force, the strong nuclear force, is charge-based. He doesn't really know anything about it.
Yeah.
It's not.
Yeah,
it's QED or QCD.
The color chart, QCD, quantum chromodynamics. Yeah.
Yeah, and Feynman was the one that championed that. That's what keeps inside of a quark, or inside of a proton, and within the nucleus, that what keeps these things together that have differing charges. So they're different charges, they want to go apart, but the strong force is stronger and holds them together.
So what do they have then? If they don't have a mathematical model, because you and I both know they don't do math. I mean, the farthest Whitsitt got was F equals ma. Remember during the debate?
Yeah, and he just wanted to swap G for A. And that was the extent of his math. For A. Yeah.
He did acknowledge Coulomb's law, but he wanted to change that subject very quickly. That's where he really started to squirm out and change.
He got nervous real quick.
Yeah, I think that's when we got into.
So here's a challenge to you, Whitsitt. Do the math. You say it's Coulomb's law. You say it's electrostatics. These things are well understood. You claim to have the high IQ. You talk down to everybody else as if you are smarter. Well, if you are as smart as you claim you are, then you will easily do the math for all of these things. You said that in high school, you blew the curve out on some particular test. That was a math test. You said that the military specifically tried to recruit you, just like they try to recruit everybody, to come into the military because you were so smart. You have said on street corners across the country that your IQ is higher than all the other people that you were talking to. So Whitsitt, use that super high IQ of yours to apply your claims. Coulomb's law, that's what governs the electrical attraction and repulsion between charges. That's what you claim it is. Show it.
Again, you and I both know they don't want to have a model that can make any prediction. They never have a model that can make any predictions in the real world.
Then it's falsifiable, and they don't want that.
Yeah. So what do they got? So all they have left then is these silly little experiments or these observations from nature. So because they don't have math, because 1 over r squared is never going to work because that's spherical symmetry. So if they really do the math, MC, they're going to be forced to acknowledge the Earth is a sphere. I mean, that's the only conclusion by doing the math that you can come to. You can't get these numbers to work with a flat Earth because, as you and I know, the gravitational strength on the edges of a flat Earth would be going sideways to the middle center of mass. And you'd be like hanging from a cliff on the wall. If it was a gravitational, big, huge, massive gravitational disk on the wall, you'd be hanging off of a cliff because the center of mass would be a lot parallel to the center there. So you just get all these nonsensical things, like all the water in the world would be in this big pool in the middle, like this big, you'd get the trees bending. And I mean, it'd be like you're walking uphill.
It would be worse than that if it was just a disk and not an infinite plane or a very, very large plane, then it would just collapse into a sphere because it's bigger than the potato radius.
Collapse. Well, that's the whole point. Yeah, that's the whole point. It would collapse into a sphere. You're never going to get those numbers to work. But you're right. If you made it an infinite massive plane, there is a way that you can get the right mass to give you 9.8 meters per second in an infinite plane, but it will not decrease with altitude. It'll stay the same constant number because the drop off from an infinite plane is constant. There is no drop off because you can't escape an infinite plane because you got vectors coming in the higher you go up, right? So it turns out to be a constant. But we know it's not a constant, and none of the flat earthers claim to be on an infinite plane, do they? Or is there?
There is the Infinite Plane Society.
Oh,
IPS.
That's a new one.
Yeah, there are those. Well, but to my knowledge, none of the infinite planers actually claim that gravity. They don't attempt to provide that as the explanation for gravity. They still go with all of the other nonsense about gravity. The infinite planers are the ones that could potentially offer that, but they still don't.
They actually could. They don't. They're in the best position to offer a 9.8. Now, it wouldn't drop off, but at least they could stay at the surface as 9.8 meters per second.
And it wouldn't vary by location or latitude or elevation. But
exactly.
I mean, it gives them step one.
It gives them step one. They can get a constant, which is a lot closer than where the current flat Earth models are at. So basically, what I was getting at here is because they have no math and no model, they resort to these little science experiments, or they just look at observations from nature, like spider ballooning. Bob loves that one, right? The bees attracting pollen, and they really think, MC, that it's levitating up to the bee. They just seem to think that because there's only one force, right? It's got to be levitation because everything is electrostatics. And I just wanted to show a little clip here from Dirth, not with the sound or audio, but I just kind of want to explain what he's trying to do here. So what Dirth is doing in this little experiment is he's got this helium balloons, right? And this little button on the bottom. And they're adding a positive or a negative, doesn't matter, charge to this button. And it's pulling it down. So they think because they can manipulate, this is why they think their experiment proves that their model is right. Because they think they're manipulating the independent variable to cause the dependent variable, right? And they're able to manipulate this electric charge to make it go down. And somehow this is a proof that things go down based on their model. I kid you not.
They didn't control for the existing downward acceleration.
No, right. They didn't draw a free body diagram and see all the forces. There's a buoyant force going up. There's a button, some mass going down. But yes, when you add charge, you create an induced, it's a London dispersion force, right? You're inducing dipoles in the floor that's then attracting, it's a very weak, but when you got a Van de Graaff generator adding 40,000 volts or whatever it is, that's a very strong, it can create a strong
40,000 volts or whatever they were needing to apply for this to work is a ridiculously large voltage, which doesn't work with their model, because if it's, according to their model, a very small voltage would cause a large amount of acceleration.
They could have saved some money. The same principle was when you rub, I got a little wool thing here. I mean, if I rub the balloon with the wool, I can stick it to the wall, right? I mean, it's not hard. Anybody can do this with because you're just transferring charge to the balloon. So this is all they're doing is they're adding charge to that button, and the button's inducing a dipole and going down. Well, guess what? if Dearth would have taken that button to the wall, it would have gone sideways. If he would have taken it to the ceiling, it would have gone up. It's nothing to do. It's just the proximity of the button to the floor that's inducing the dipole in the floor, right? I mean, this is. I mean, I don't understand. They think this is such great proof. And one more. This is Dearth loves this one too. This aeroelectrodynamic thrust type of thing. So now what he says is now we're going to go in the other direction. Okay. So the first experiment was Dearth saying, look, we can prove that electromagnetic force makes things go down, right? Now I want to show you that we can also manipulate to make things levitate and go up. And it's not even electrostatics really, because it's what it's doing. It's ionic wind, right? You're actually creating a corona discharge from the needles, and the air is getting pushed along with the electrons, and it pushes it up like a thrust.
The Dyson fan that's just a circle and has no blades in it. Yeah. That's what this is. That's what.
Oh, okay. I didn't realize that. But now then he's got the MIT one too, where MIT's got a really, and it's a cool technology where they can use ionic wind to create but it when they did their experiment, the plane didn't go very far, and they had to use 40,000 volts, right, to get it just because again, it's corona discharge. You're going from a thin electrode to a thicker one, and so the ions will, because of the high curvature, the ions shoot off the thin electrode, and then it'll attract to the thicker one, and that creates a flow, just like an airflow across a wing, right? But now you're creating airflow in a different way. You're creating it actually from the needles, and you're kind of forcing. So the lift that's created in these planes that MIT developed, it's similar to lift in an airplane. It's just the airflow is coming from the ionic wind, from the corona discharge of the ions.
Oh, Ben D said that they don't work in a vacuum. That's a great thing.
Oh, right, exactly, yeah.
And that's
and
using
they won't work at high altitude. They don't work at high altitudes either, because you need a certain density of air for it to flow enough air, enough air to flow over it.
So you could put it in a chamber and evacuate half the air and half the pressure. It would start to affect it.
But when they say that, when you hear these flat earthers say we can prove our model, this is their proofs that they're talking about.
Yeah.
And it's like, and I went through, if anybody wants to watch my last video, I did a whole video on flat earth science, quote unquote science. And I went through a lot of these things, and absolutely none of them prove their model at all. They just prove that our current science works.
Yeah.
And we actually understand all the forces that go on here. And flat earthers only seem to think there's one force acting on a body at a time. They can't seem to draw a free body diagram to save their life.
And for reference, a free body diagram is just where you draw all of the forces and the directions that they're applying to an object. So the downward acceleration, gravity in our case, in their case, it's whatever. They don't quite have it defined well. But it's gravity, it's buoyancy, which works in the opposite direction. It's wind resistance if it's moving. It's electrical charges, just like that, right? Like they say, electrical charges is one of them. If they're not at the, but you don't need to include them normally unless you need lots of precision if they're small. So you wouldn't normally include electrical charge because it's going to be pretty deep in and probably much less than most measurements margin of error could even touch.
The thing with electrostatics is usually most electrostatics are on insulators, right? Because conductors, the charge is all kind of spread out.
Yes.
So insulators are better to hold electrostatics. So really electrostatics in our daily lives is like when you rub your feet on carpet or your dryer or your little balloon thing I just did. Of course, lightning is an example, but most things around us, I mean, I've got this little electrostatics meter. You can measure, most things are electrically neutral.
They don't have anything. Yeah.
There's no, I mean, where is, like, if it is a negative charge and that would mean everything has to be, I didn't mention this. That would mean everything has to be positively charged. But then if everything's positively charged, attracted to the negative earth, that means that those positive charges repel. So we should all be repelling each other. And it's like just so many contradictions in their model, right?
It's just, they don't think to step two. They're like, step one. And then that's it.
This is not one or two, MC, this is not one or two problems we're going over here. This is like a baker's dozen at least. I mean, we've gone through
it goes on and on and on. It's the same problem. Many things in flat Earth that they offer one explanation, and then that explanation contradicts 10 other things, right? And I call them off diagonal, right? So they make a claim for here's a problem, here's the answer. Here's another problem, here's another answer, and it makes this diagonal problem answer, right? But every answer contradicts a handful of other answers, right? And so they have these off diagonal conflicts that happen, and they just ignore them. They can't think about them.
Yeah. No, and maybe that's a better way of saying kettle logic, so we don't get more fallacy things going. But but it is kettle logic. I mean, in the way that fallacy is defined. But it's just so they resorting to these experiments, and I mean, I don't know, how are people just watching this and saying, "Oh, wow, that really does prove it." I mean, I don't. It just
because they're not that bright either, right? And this is the thing, Austin. You're not that smart, and the people that you fooled are less smart than you. That's how it works when you're fooling people, at least in that particular subject.
Yeah. The most interesting of these experiments, well, the spider ballooning to me is kind of fascinating because this one had the most forces acting at once, because you did have electrostatic. There was a little of electrostatic attraction of the negative charge on the web, right? That helps to carry it upwards.
Yeah.
But you also had like lift, like a lift force from the parachuting effect of the spider web. And then you had the drag force, because the spiders have to be less than a milligram in weight, otherwise it doesn't work. So, and then you also had, of course, gravity, right? So when you draw the free body diagram of spider ballooning, you got like at least 4 different forces acting on that. So when Bob does the analogy, when he explains it, he says it's all electrostatics in his explanation.
Yeah. So
and at least when I watch it,
and they don't even begin to come close to anything in the realm that you might even propose as proof, according to them, because you didn't. You need to eliminate other things, right? Did they eliminate in these electrical things? Did they eliminate gravity? No, they just identified that something made it go up. Did they eliminate buoyancy? They didn't take that into account. They didn't know how much. They didn't do any of those things. All they did was, something went up, therefore proven. No.
Yeah.
If you look at the actual like published science that people do, the really good ones, they spend pages and pages and pages going over all of their effort that they put into controlling the conflating or confounding variables so that they know that what they're doing is actually what they're seeing, right? That it isn't something else messing with them.
Yeah. So this is kind of where, I mean, this is kind of the end of it. We can certainly open up to more questions here. Mm-hmm. And to me, I mean, it's a pretty brutal death, actually. It's not just death by one cause. It's like, 13 or 14 fatal bullet wounds coming in from all directions, right? I mean, and I don't know, what can they say to all this? I mean,
they'll just show one more single experiment where it was essentially the same thing.
Yeah, just somehow manipulating electrostatics to create. I mean, again, it's the electrostatic force they're playing with. And ignore all other, pretend that none of the other forces exist. Hand wave dismiss the many measurements of mass attracting mass. They won't even look at that. Yeah.
They just hand wave that away.
Well, my hope is that people that are still on the fence that are watching this can just kind of take this in, and it's like just kind of soak it in and just really critically ponder what these guys are saying. It's like, and just look at all the ways they're contradicting themselves.
Flat Earth Dweller just said, and here is the essence of a religious cult. Just said, I want to read it. Said, there is no evidence that mass attracts mass, period, and then lots of exclamation points. Sorry, denial is not refutation. MCToon.net/G has 18 measurements of the strength.
Good stuff, too.
The strength of mass-to-mass attraction. You did not do anything to refute them. You did not find flaws in their methodology. You didn't do anything at all to actually address the evidence for gravity. You've only made a religious claim. That's all you've done, flat earth dweller. That doesn't establish the shape of the earth. That doesn't establish whether or not gravity exists. All you've done is go to religion.